core 1, core 2 and we have 4 cores. Each core has some L1 cache and L2 cache, L1 and L2 cache, L1 and L2 cache, L1 and L2 cache. Okay. Now you have a shared LLC, last level cache that is shared among all cores. Okay, these are the questions. And then you have interface this with memory. Okay, let's assume there is some simulator available. There are a lot of simulators available on the internet. Like I may tell you different type of simulators, and I may also give you the code. And these are open source simulators. Okay. Now, if let's assume these simulators are C++ based. So actually, you have some classes. Okay. Class. So actually, you will have a class for each core. Each core. So there will be a class of core. Okay. Now, if you want to instantiate 4 cores, how many objects do you need? 4 objects. So you need a for loop. For I is equal to 0, I smaller than n, I plus plus, and you have to create an object of core of I is equal to, say you have new, you have to instantiate the constructor of core. And with these constructions you have some parameters. Okay, now if you look at the class core, it consists of many objects, classes within. So we can also define class cache L1, class cache L2. Now within this core constructor, if you look at this core constructor, within the constructor of the core, so in core constructor you can instantiate 2 cache. What? L1 new and L2 new. You are instantiating this. Not only this is about L1 and L2, but if you look at the core, there are different units. Instruction fetch unit, instruction decode unit. So actually you have fetch unit class, decode unit class, load store unit class. Okay, register file class. Okay, how many parameters? Now if you look at the cache, so cache, maybe some of you have studied, and you will study also cache in more detail. But in cache, what parameter unit? How many sets are there? What is the associativity? What is the cache line size? So within class, so if you cache, so if you want to have new and cache, like you're instantiating this new L1. So what are the parameters? Sets, associativity, line size, and these are the parameters. Okay. Now, how do you get these parameters? Like now, so naturally, there is one simulator. There is one big simulator. Okay, that has all of these objects. Okay, so you have one separate class for core, one separate class for cache, one separate class for instruction fetch unit, for decode unit, for execute unit, load store unit within the core. So it means instruction fetch unit, instruction decode, execute unit. Okay, a lot of units are there. Register files. Then in register file you can also initialize how many registers are there. Okay, and what you do, you have one configuration file. What? One configuration file, like config file. And in this config file, you can give different values for different parameters. For instance, one of the parameter can be like this, like minus L1. Minus L1 means what are these parameters? These parameters are relative to L1 cache. L1 cache. So let's assume these parameters are like this. So minus L1, let's assume, and we say sets associativity, line size. So it means how many sets are 256 sets are in L1. What is the line associativity? Add. What is the line size? 64 byte, and so forth. These are the parameters. Similarly, you will have parameter for L2 cache. Now you have like register file size. Okay, and okay. Once you instantiate these cores. Okay, now how many instances of the core will be created in this particular example? 4 instances. So actually in parameters we can also have one parameter number of cores. So how can we set this parameter? To 4. If you want 8 cores, then it will set to 8. And this parameter, this is 4, and this will go here to this. And okay, I just want to answer. We can also get number of cores. So whenever you want to load a simulator, first it will read all the parameters from the config file. All the parameters for the config file, and within the code there are a lot of parameters. Now let's assume a scenario. Let's assume a scenario you want to do some research in cache. You want to do some research in cache. Then there is another question. Which type of cache? Private L1 cache or L2 cache or shared last level cache? So okay, now then where do you need the modifications? Only in one source code. What is maybe their code is llc.cpp and llc.h. Why h? Header file. CPP, C++ file. You only need change in them. But to incorporate these changes, you need to know the overall structure of the simulator. How does simulator works? And for this simulator, there are some benchmarks. And these benchmarks, traces, there are like traces, input, output traces. For each benchmark, there are traces. We call it EIO, execution, input, output traces. These are input, output traces. And it is like, it is considering this trace file and giving this trace file as a code. Code will execute the instructions, like the instruction one by one. And then, now if you look at the, if you want to simulate any memory, any type of memory. Memory can be cache. Cache is also a type of memory. Okay. If you want to simulate any memory, so there is one simple model. This is a requester, and this is a memory. Requester will make a request, and memory will provide the data. This memory can be in L1 cache, it can be L2 cache, it can be last level cache, or it can be an object main memory. Now, if you look at this requested model, so simple model. So if we set a request and then it's a response. It's a request and it is a response. So the requester will send a request to the memory and the memory will send the response to the requester. If you remember in the last lecture, we defined something that is called as an access time. You remember? Yes, sir. Access time. Access time is the time between a request is made and the response become available. Now if you look at if we have now if you want to have a very simple model, in a simple model we have a fixed latency model. If you have a fixed latency model, if we say okay, this memory will provide the data in t access time, and this t access time is what? Fixed. Okay, now how can we set this t access time? How can we initialize this t access time? अब देखिए मैंने सारी बातें आपसे पहले की हैं. How can we initialize this? Through what? Config file. अब देखिए अब मैं वहां पे then you need to change some this in config file, and in config file we say okay, then this is our size of the memory, and now then you also have one parameter like memory. Then one parameter is called latency. Now this latency is fixed or variable? Fixed. So it means, let's assume if the request will make a request at cycle. Now there are also some cycles. If you look at the processor, cycle 0, cycle 1. So if you look at this clock. This is rising edge of the clock, rising edge of the clock. So this is T0, this is T1, this is T2, this is 1 cycle. So the simulation is progressed at each cycle. So we say cycle 0, cycle 1, cycle 2, cycle 3 and so forth. Okay, so now let's assume if you make a request at time Ti and the latency of this memory is TAC, so when you will get the data? When you will get the data?
TAC minus T.
Ti plus TAC. Am I right? Let's assume current cycle is 5 cycle. The latency is 9. So you make a request at time T5 and you will get the data T40. And the difference between these two is the latency or access time. अभी अच्छा यहाँ पे हमारी assumption क्या है? Access latency is what? Fixed. Is it possible that access latency is fixed? No, sir. It's variable. Now if you remember in rest-stack memory, if you want to model a rest-stack memory, is the fixed latency model a true representation of rest-stack memory or not? No. So this model can be valid for SRAM, yes or no? For SRAM. Is it fixed? Because that is random. If you remember in your previous lecture, we said that SS latency is same independent of the location to be accessed. Remember? Right? Or my the access latency is fixed. There was a reason because the decoder. We had a decoder, and some I also told you that the decoder latency is fixed. If you remember, okay. Now if you want, let's do. Now you have a fixed latency model. You have a fixed latency model, and you want to modify it for rest-stack memory. Okay. Now it's a question. अब देखिए यहाँ पे क्या हो रहा है? वहाँ पे memory के concepts हैं. यहाँ पे आप सॉफ्टवेयर इंजीनियरिंग की कॉन्सेप्ट्स आ जाएंगे, प्रोग्रामिंग की कॉन्सेप्ट्स आ जाएंगे. व्हाट मॉडिफिकेशन डू यू नीड? व्हाट एडिशनल पैरामीटर यू नीड टू इंट्रोड्यूस?
सर डायरेक्टली कॉन्फ़िग फाइल में तो नहीं है वो कर.
नहीं, कॉन्फ़िग फाइल देखिए you can create. So actually if you look at this, so now if we say we have a memory.h file, okay, and there is a class memory, and in the previous class we have one parameter, integer access latency. Integer access latency. And what we are doing, so when we are integer access latency, so what we are doing, so we have one parameter in access latency, and this access latency we were reading from the config file. नहीं समझे बेटा? ओके, सो हम क्या कर रहे हैं, हम ये भी कह सकते हैं, अगर हम सी की बात करें, स्कैन एफ का यूज करें, स्कैन एफ और सी इन सी प्लस प्लस. ओके, तो इसका मतलब है कि नाउ वी आर यूजिंग एंड स्कैन एफ एंड एक्सेस लेटेंसी. सो वी आर रीडिंग फ्रॉम द config file and storing that parameter in which variable access latency. And when this access latency should be initialized? When should be specialized? When an object of class memory is instantiated. When that will be instantiated? When you will call what? The function, okay? When you are assigning any values to a variable in C++. So how do you assign that function? Interfaces. What are the interfaces? Function. What is the name of the function at the time of the object creation? Yes. What is the name of the function? Constructor. constructor. Okay, so you will initialize the constructor. From that constructor, from here you will read the value. From which file? Config file. From config file you will read the value and you will initialize this access latency to that value. समझ आई बात? Okay. Now, if you want to, आपको शायद नींद आ रही है. Okay. Now, if you want to model a racetrack memory, what additional parameter we need in this class? What additional parameter do we need in this class?
जो प्रॉब्लम है
आप नहीं आएंगे?
नो सर, मैं सीएस की स्टूडेंट हूँ. लास्ट टाइम क्लास नहीं दे सकती थी, कभी फर्स्ट क्लास.
अच्छा ठीक है. Okay, so in access latency प्रॉब्लम ये है कि मुझे दोबारा सारा रिपीट करना पड़ेगा. ये बहुत ही मुश्किल काम है. फिर जब आप लेट आते रहेंगे तो फिर बड़ा मसला होगा. Okay, now if you remember in the racetrack memory, if you remember, so what additional parameter do we need for racetrack memory?
So we had different tracks and domains
Track and domain.
and the position of the
Correct. Okay, so then we need some kind, not only access latency, but we need current position, current and int current position, and it required position. Then you also need to have parameter in shift latency. What is the latency of one shift? Now let's assume you are here and you want to move from one domain for one domain shift. For one domain, what is the shift latency? These parameter needs to be constant. आप समझ आई बात नहीं? तब ये this is the whole type of the infrastructure on which I am working. So if anybody is interested in these kind of things and doing research in this kind of thing, he may come to me and then we can discuss in more and more detail. Okay, you got my point? So whenever we are evaluating any idea, so we evaluate it on a simulator. We evaluate it in a simulator. This simulator is actually based on C++. All the concept of object-oriented programming will be used. So now I am repeating it for you. Let's assume that we are simulating a multi-core scenario in which we have 4 different cores: core 0, core 1, core 2 and core 3. Each core is just like a processor. Each core consists of different components: instruction fetch unit, decode unit, execute unit, register file, L1 cache and L2 cache. So if you want to have this kind of, we want to simulate this kind of system, so we need a simulator. And this simulator is C++ based. When it is C++ based, so actually if we have working on this simulator, so you need some classes. So actually we will have a class of core, and within this class we have different subclasses. One for instruction fetch unit, one for decode unit, one for execute unit, one for L1, one for. So let's assume if we want to simulate 4 cores. Okay, so we can have a loop for I is equal to 0, I is equal to the number of cores I plus. How you can initialize this core data? You can initialize this core data from the config file. You are reading from the config file. So in config file you have some like parameters like number of cores. You are reading that file. Okay, if you want to simulate 4 cores, so what will be the parameter in the config file? Number of cores will be set to 4. But if you want to simulate 8 cores, then 8. Okay, so this multi-core simulator will be reading the these parameters from the config file, and it will create instances of different objects. So in this scenario, how many objects of core objects will be created? 4 objects. How many instances of last level cache will be created? How many last level cache? 1, because it is shared among all cores. How many instances of memory will be created? 1. Now let's say if you look at a memory, let's say we have a DRAM memory. DRAM memory consists of, let's assume, 64 banks. So we have one class for one bank. Bank 0, bank 1, bank 2. So we can have a class of let's assume if we have a memory, and for memory, let's say we have object memory. In object memory, so we have one class of bank, then class of memory. So in class of memory, we have two parameters: in number of banks and number of banks. How you can initialize this number of banks? From which file? Config file. Where it will be initialized? In the constructor of which class? Memory. In the constructor of memory. So this number of banks will be initialized in the constructor of memory. Acha, if we have class bank, so actually we can have class bank staring instance of bank. How many instances we need?
64.
Depending upon the number of banks. The number of banks from where it is initialized? Config file. So can we have like this kind of a code, simple code? अब ये सारे concept आप कौन किसके concepts हैं? C++ के, मैं और कुछ नहीं कर रहा. For क्या होगा? I is equal to 0. I is smaller than number of banks. I plus. Okay. Then bank I is equal to new. In bank instance of a new bank. Okay, and within the new bank, okay, if you look at the bank consists of rows and columns and things. So actually, if you look at this whole infrastructure, actually all of these, your concept of object-oriented programming will be tested here.
सर जो शेयर्ड मेमोरी है LLC इसकी भी अलग से क्लास बनेगी.
इसकी क्लास होगी. If LLC actually it is a class of a cache. This is also it is L1 of a type cache, L2 of type cache, LLC of type cache. But the only thing is this here LLC is shared and there are private. Maybe the LLC has more parameters. If it has more parameters, you can use inheritance.
That's what I
Yes. वो जो सारे concepts होंगे. But actually, let's assume if I say, okay, now we have a problem. We want to solve this problem in our simulator. How do you do programming? It's up to you. Because the base simulator is available. But if you let's assume if you say now if you look at the cache, in cache there are some replacement policies. There are some replacement policy. If you want to change the replacement, you can have these change the replacement. What can be the replacement policy? First in, first out. Round robin. Least recently used, least frequently used. We will study this in more detail. But if we want to change the replacement policy, so we have to change one function of the class of which class? Cache. That function of the class? Cache. And when we change the function of the class cache, we can achieve an object. ठीक है? तो ये जो है how do we simulate like a multi-core system? So if somebody wants to do any research, so we can discuss this in that. So off कर दूँ.